paper. So we are in chapter 5. We're going to start section 5.2 today. But I'm, just going back to what did we learn in chapter 5 up to this point? Let me adjust my camera here for a second. Get it up here. We had all of our identities. And a big one was sine squared of theta plus cosine squared of theta equals 1. And we made a whole bunch of different, we made 2 other identities to go along with that. And, in this chapter and talking about identities, we also had one that was the tangent squared of theta plus 1 equaled the secant squared of theta. And a couple of times now we looked where that comes from. That was from dividing everything by cosine. If I divided everything by sine, and you all have your ways of remembering these. One is the tangent plus 1, the other is the cotangent plus 1, where they come from. And we kept going and we made a big inventory of things that we would be able to use down the road. We even did one of them was an even function. And we said for evens, the cosine of theta equaled the cosine of negative theta. And then we had the 2 that were odd. That was the sine and the cosine. And we said the sine of theta equaled negative the sine of negative theta. And the tangent of theta equals negative the tangent of negative theta. And we looked at y equals x squared and y equals x cubed. And we talked about all that. And, not going to spend much time on it because we did last class. You have a video ready. And, if you had to go back and check that out, you could. One of the last things we did was we looked at an equation and we messed around with the equation and changed it with things we know. And that's going to lead into what we're taking a look at today. And that's this thing called verifying identities. All right. So what do you mean by verifying an identity? Well, an identity, it's like an equation. Okay, I have an equation. What's on the left is definitely equal to what's on the right. And this verifying hopefully doesn't scare you, but it's a little bit like what you had back in geometry in high school. It was called a proof. And you had to draw on your prior knowledge of things that you learned. And we have a whole inventory of things that we have tucked away that we can learn. But this section 5.2 is our first introduction to doing this verifying of an identity. All right. So what we have here is a big mess. And the idea of verifying an identity is take one side, either the left or the right, and work with it to make it look like the other side. Okay, I want to take one of these 2 sides and do stuff to it. There's lots of things I can do, but my goal is to do some work here, be it algebraically, like distribute. I'm allowed to distribute, be it change into cosines and sines. We did an example like that in section 5.1, or a variety of different ways to solve it. When we go to verify an identity, normally we want to start with the biggest side, and that's that right side. So for this guy, we're going to let the left side alone, and I'm going to go through and manipulate the right side to see if I can turn it into the left side. And if I can, then that means this guy definitely equals that guy. And for all these identities, that's just the way it is. Okay, so an idea. First thing I might do is an algebraic event like distribute. Okay, so the cosecant of x, cosine of x, plus, when I distribute, and then I go over here, I get the cosecant of x times the sine of x. I'm not touching his left side. Can't touch that. Hammer time. Mr. Birmingham is here. Good morning, Ethan. I think I saw Emily came in. Emily, you're here, right? Oh, yeah, I already had you, right? Tomas is here, Philip's here, John's here. Okay. Doesn't look like the left side yet. Somebody have an idea of what we could do for our next step? Because algebra is easy. We know how to distribute. Think back to what we did last Wednesday, because Monday was our test.
Combine like terms.
Combine like terms. Help me out a little bit with that. What do you mean by combine like terms?
Like the cosecant, both of the cosecants.
You want to pull them back out?
No, like add them together.
Well, we can't really add these because they're not the same. Whole thing has to be the same to add them.
Oh, okay, sure.
Okay. No, that's a good idea though, because we're going to end up doing some of that later.
Are we turning cosecant into 1 over sine?
Excellent. Excellent idea. When I get in trouble, and this is what we did on Wednesday of last week with the directions that said, change everything into sine and cosine. So if I took this, I would get 1 over the sine of x times the cosine of x, plus this guy right here is 1 over the sine of x times the sine of x. Legal. Legal. Everything's still good. It's pretty. Even my bad handwriting looks legible. If I multiply these two together, I get the cosine of x over the sine of x. If I multiply these two together, I get the sine of x over the sine of x. I'm starting to get excited now because when I distributed, I got down to 2 terms. And that's what I wanted, 2 terms. And now I can go and say, oh, this was something. Yeah, this was the definition of the cotangent of x. This was something, and this is 1. And I go, oh, woohoo! I verified that identity. Check. I'm hoping that 1 or 2 of you saw it right away and off you went. Okay, cool. Number 2. We're going to practice the heck out of these today. And this is one of those where if I didn't record it, there'd be some lost people. How about this guy? Tangent squared of x times 1 plus cotangent squared of x equals 1 over 1 minus the sine squared of x. What side do you think you want to work on? I have an idea which side I'd like to. Yeah, the left. The left. All right, so I'm going to pause. I'm recording. All right, so a person just suggested, that guy looks familiar. Can I use the identity, the Pythagorean identity, and say, wait a minute, I know this one. That guy right there equals, what does he equal? The cosecant squared of x, right? The cosecant squared of x. So absolutely, I can make this tangent squared of x times the cosecant squared of x. Another thing you could have done is made this sine squared over cosine squared. This becomes cosine squared over sine squared, distribute. But I think we did a potentially a time saver here. I may now want to do that. Convert to sines and cosines just to see what happens. This is the sine squared of x over the cosine squared of x times 1 over the sine squared of x. And it looks like they cancel. I'm left with 1 over the cosine squared of x. And I do remember the sine squared plus the cosine squared equals 1. So cosine squared does in fact equal 1 minus the sine squared. So I can convert that because that's what I want to get. Woohoo! Check. Left side equals the right side. Very good, Chow.
But Professor,
Yes.
He can go first.
okay.
ahead.
The cotangent, is it not sine all over cosine?
The cotangent is cosine over sine. But what we did was we had a Pythagorean identity. We had this one, we had 1 plus the cotangent squared equal the cosecant squared. And we had one that said the tangent squared plus 1 equals the secant squared. So we have those tucked away in our library. And Chow went, well, wait a minute. If I have this, can't I replace that with cosecant squared? The answer is yes. Absolutely. That was great to recognize that.
I don't get it.
I've
But why
got
don't you,
Go ahead.
Go ahead.
Patrick, go ahead when you're done.
I just got a question. If you multiplied that through in the beginning,
Yes.
would you get tangent squared x plus 1?
So if I distribute what's anything times its 1 by times 1, it
Tangent.
becomes itself, right?
Right.
So let's see, that would have given me the tangent squared of x plus tangent squared of x times the cotangent squared of x.
Okay.
Right. Is that 1 or no?
So this right here would become 1. Yes.
Okay.
Yep. That would become 1. So now I would have tangent squared of x plus 1. And if I come over here, I'm going, wait a minute, that equals the secant squared. And the secant squared is 1 over the cosine squared. So it would just be another direction to solve this identity. Absolutely.
Okay. Gotcha. That's what I did.
And a lot of folks will quickly change this into sines and cosines to start. That could be another direction to go to solve these. But yeah, if we distribute and you recognize this is sine over cosine, this is cosine over sine, lots of canceling, I get plus 1. Shoot, question. Or did that help?
I'm lost.
What we could memorize for everything could be helpful recognize when we know what the next step to do when you know.
Right, and that's verifying identities. There are lots of what could the next step be? And, I've done so many of them, I look at them and know right away what I'm going to do. But for you, you're looking at them going, well, where do I start? Again, a simple way would be to come back and say sine squared of x over cosine squared of x. That's this.
Yeah.
Times 1 plus, and this is the cosine squared of x over the sine squared of x. And when you're first doing these, getting your feet wet, that's not bad to make it sines and cosines. So now when I distribute, I get sine squared over cosine squared plus, when I distribute here and here I get sine squared of x over cosine squared of x times cosine squared of x. Sorry, I'm writing sloppy because I'm excited. Over sine squared of x. These guys all cancel. So that would give me a 1. Now I'm looking at, oh yeah, this is the tangent. So lots of different ways to attack this. But in the end, it should equal the right side. I have a note, page 323. This is called a textbook, and they put stuff in the textbook. And I understand today's world, we're getting away from textbooks, but hints for verifying identities. I don't need to write them down because they already exist. You have an e-text, you could go look in the e-text on page 323, but it's the same kind of thing. Learn the fundamental identities. especially sine squared plus cosine squared equals 1. There it is. Boom. And you know, there's always alternate forms that exist. We decided try to rewrite the more complicated side. We've done that both times. Okay. Write everything in terms of sine and cosine. We've done that. Number 2, that was our third attempt. We did it. Algebra operations. Well, we've distributed a couple of times. That's an algebra operation. But all of these also exist. If I square a binomial, that's the same as x plus y times x plus y. That's where that middle term comes from. This is something that should have been beat into your head over and over and over. This doesn't equal x squared plus y squared. There's a middle term in there. Cubes are just stupid at this level. So, you know, I don't even want to talk about cubes. The product, that's multiply, of a sum and a difference equals the difference of perfect squares. We've seen that. Down here, substitution. You know, if you know your identities, you're able to substitute. The last one on this page, multiplying by the numerator and the denominator by the same thing, a version of 1, right? If I multiply anything times 1 is okay. If I multiplied it by 6 over 6, that's still a version of 1. If I multiplied by cosine of x over the cosine of x, that's still a version of 1. So I can look at one side and multiply top and bottom by the same thing. Great page. Saved me from doing a whole lot of writing. That page 323 in your textbook. Can we do another one? Well, sure. Let's do another one. I can just tell the excitement in your voices. Seriously, you sound excited. How about this one? Tangent of t minus the cotangent of t. And I don't know why the author doesn't just use theta for angle measures. Over sine of t, cosine of t equals secant squared of t minus cosecant squared of t. This is true. This is the truth. It does equal it. We just now have to make it equal it. I'm going to pause. All right, I'm guessing all the groups got this. Is that correct? Y'all figured it out?
So left side or right side first, Professor?
You wanted to do the right side first.
Because I think the left side is already simplified, you know, but the right side is square. It looks like something to do. That's what I
Okay.
think.
All right. Sergio, what side did your group talk about? Left or
we're discussing the left side, but we
yeah.
didn't get much far.
Okay. Philip, your group?
Yeah, some of us finished it.
Okay, what side?
The left side.
The left side. Yeah, I was thinking the left side as well, but Chow said the right side. And how far did you get on the Chow? How far did you get on the right side?
Because I could do with the secant square. I could transfer. I could do like I think the first question you got is show us about 1 over cosine square.
Mm-hmm.
Minus 1 over sine square.
Mm-hmm.
That's what I'm figuring out about the right side first way first.
Okay. Yeah, lots of different ways to do this. It sounds like most people, and somebody solved it with the left, so we're going to go with the left. But one thing I note is 1 term, 2 terms. This is 1 whole term. So if I'm gonna work with the left, I probably want to split it up. If I'm gonna work with the right, I want to combine them. So I'm gonna go with the left, Joe. I'm gonna go with the majority in case I screw it up because I heard somebody got it done. As I mentioned, this is two terms, so I'm gonna make it two terms. The tangent of t over sine of t cosine of t minus the cotangent of t over sine of t cosine of t. All right, I think Philip, you said you guys were able to finish it?
Some of us did. I
Yeah.
don't think.
Oh, so it wasn't much conversation in the group together?
Some.
Yeah. Did anybody have a
Yeah.
quiet group? Hate quiet groups. Well, to divide is to multiply by the reciprocal. So I'm gonna write this as the tangent of t times 1 over sine of t cosine of t minus the cotangent of t times 1 over sine of t cosine of t. And again, the more of these you do, the quicker these tricks will come up. This is just a model, to divide is the same as multiplying by the reciprocal. Now, I'm gonna change tangent of t into what?
Cancel terms.
Well, not yet, because this is sine and this is cosine. So I really can't cancel with anything yet, but what
Oh,
you
you
might,
got put sine and cosine tangent.
yeah, change the tangent to sine and cosine times 1 over sine t cosine t minus, this is gonna be the cosine of t over the sine of t times 1 over sine t cosine t. And as you can tell on the next test, when you're verifying an identity, you're gonna have to write it on your scratch paper and submit it right away, not an hour later or 2 hours later, because I start to grade them. You need to upload your work for partial credit right away so that I can go through and see that you understood how to do this. All right, Sergio, now tell me what to do.
Oh, now you can cancel
Yeah,
the
yeah, great.
the like
Now,
terms and
yeah, there goes sine, there goes sine. I'm left with 1 over the cosine times the cosine is the cosine squared. I'm going to cancel over here. I'm left with 1 over sine times sine is the sine squared. And I'm almost there because I keep peeking at my answer. And I know, yes, this is in fact the secant squared. And this is in fact the cosecant squared. And I'm going, woohoo, got it. Bam, drop the pencil, drop the mic. Do, 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 do.
Can you tell me if I did this right?
Yeah,
So, wait, let me look and see what I actually did. Okay, so, I converted tangent of x. Or wait. Yeah, so I converted tangent and cotangent to. So cosine over sine minus sine over cosine, all divided by sine times cosine.
okay.
And then I combined, or
I'm gonna do it brief. I'm gonna do sine over cosine minus cosine over sine cosine. Is that okay?
yeah.
Yep, go ahead.
Okay, so then I made a proper numerator and denominator, like combining those terms. So
Okay.
that would be sine squared minus cosine squared over sine cosine.
So what you can do is you can say, okay, I have a mixed fraction, right? I have fractions in the top and I have a term in the bottom. What if I multiplied everything in the top by sine and cosine and everything in the bottom by sine and cosine? Okay, so if I take this times the first term and times the second term, and I take the bottom times, there is only the one thing, I can now start to take a look at what I see. So this is a way to clear the denominators in an improper fraction. If I take sine and cosine and put it in here, the cosines canceled, I'd get the sine squared. If I took, is this kind of what you were thinking about doing?
Yeah, that's exactly what I got.
Okay,
And then,
right. And
Or-
now, again, this is two fractions. So I'd want to break this up into two fractions. So sine squared over sine squared cosine squared minus cosine squared over sine squared cosine squared. This would become 1 over the cosine, which becomes the secant. This becomes 1 over the sine, which becomes the cosecant. So absolutely. And this was one of that one near the end step I said, multiply by a version of 1, something over itself. And when I distributed, I'm glad you brought it up because this gave us another way to go through solving this problem. And again, I got lazy and didn't write everything out, but I think you understand what I did.
yeah,
Yeah. Yep. Yep. And this was a concept that you learned before this class. Oh, when will I ever use it? Well, here's one instance. Coming back, you're clearing the denominators by multiplying the numerator that has fractions in it and the denominator by the same thing. It's like multiplying by 1, so it didn't change my problem. Excellent. I like it. I love it. They're like puzzles to me. Did my Wordle today, 3 tries. That's what I'm talking about. That's 4 out of 5 days I did Wordle in 3 tries. Stupid game has me hooked now. Let's take a look at one more. We have plenty of time. This is good. This is great.
So if I start with the right side first, and I would just like my second step is just like your almost last step in there. That's why I said I'm talking about.
Mhm. All right, I'm going to
No,
pause the
no.
recording. I'm going to throw you back in the group. Here we go with the recording. What do you think? This could be a quick hitter if you knew what you were doing. Chow shakes her head. No, no, it's not.
I mean,
No
I saw that
idea.
I saw you can make the equal to 1, but other than that, I didn't know where to start on the right side.
Okay, so oh boy, yeah. Wouldn't it be great if I had this in the denominator over here? Okay, so the cheat, and again, the more you do of these, maybe the better you get. What if I multiply this by 1 minus sine of x over 1 minus sine of x? Well, whoop-de-doo. No, not whoop-de-doo. What's the numerator become? Well, I have a binomial and I have a binomial. 1 minus the sine of x plus the sine of x. That's gone. 1 minus the sine squared of x over cosine of x times 1 minus sine of x. And some of you may be going, I don't know what you're doing, why you're doing it. When we get the result, you'll see it. And then some of you go, how did you know to do that? Well, you have to do some to learn some of these tricks. What is 1 minus the sine squared? Oh, he does his little shortcuts. Sine squared plus cosine squared equals 1. So 1 minus the sine square. Oh, check it out, Funk Soul Brothers. That becomes that. Cosine of x times 1 minus the sine of x. cancel a cosine of X from the numerator and the denominator. I'm left with a cosine of X in the numerator. In the denominator, I get 1 minus, well, whoop-de-doo. What do you think about that?
Okay, how do we know we have to multiply it by 1 minus sine X?
Practice. The more you do, the more you learn these. And again, you know, this is something that you need to keep in mind. The product of a sum and a difference gives me the difference of perfect squares, as it's called. But I know when I see the 1 plus X, and if I go 1 minus the sine of X, that it becomes this, and I can convert that into cosine squared. So again, it's a matter of the more you do, the better you're going to get at them. You can't sit and watch me and, you know, do these without doing some yourself. This is one of those old school, do homework problems number blah, 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 blah from the back of the book. And as you're doing these, the better you get.
You also do the left side or no?
Yep, same way. What would you multiply left side by?
1 minus sine of X?
Not minus, but 1.
Or, oh, but,
Well, yeah, 1 plus, because we want to get a sum and a difference.
oh, I see. Okay.
Yeah, that
Yep,
way that middle term will cancel. Yeah,
that makes more sense now. Thank you.
yeah. Some of you are
Oh.
starting to nod your head like, okay. Some of you are nodding your head left and right going, oh, hell no. That's
It's make me
okay.
remember high school when I'm learning for a square, subtract b square has something because you modify for you
Yep.
get that thing. It's make me remember from high school. Oh, that's a new way to do.
And again, the
Yep.
product, because I'm multiplying, of a sum and a difference equals the difference of perfect squares. So everything that's in my inventory, algebra wise, and we've learned up to this point, can be possibly thrown into these bad boys. All right, last one. I don't want to get your brains on overload. And I'm looking at this guy and I'm going, holy sh. And this time I don't know that it matters what side I pick. But I do know a couple of things. That looks familiar to me. That looks familiar. And in fact, if I got excited and I wanted to start on the right side, I may write that numerator as 1 plus the sine of theta squared. You see it?
Yep.
Yeah, so there's my algebra again. And this is one of those where, okay, so I started on the right side because I got excited and I got to here and yeah, no, it didn't get me very far. Didn't get me very far. So now I might want to backtrack. I'm not going to erase this because I might start working on the left side and get to that point and go, oh yeah, well, if I can get to that point, I know I can get to that point. So that's just there, but I think I'm going to switch over and work on this side. Okay, I can do that. If I'm in trouble and I throw my hands up like I just don't care, I might rewrite this as, because I'm not seeing anything just yet. I could do that secant of theta plus tangent of theta and get that kind of thing going. But I think I'm going back to my roots. And my roots say, the roots are on fire. 1 over the cosine of theta plus sine of theta over the cosine of theta divided by, okay, 1 over the cosine of theta minus sine of theta cosine of theta. And wait a minute, I just learned something recently that I can use here. What is that? What might be a next step here? Well, I have an improper fraction. I might want to get rid of those denominators. So I can multiply everything up top and everything down bottom by the same thing. What would I like to multiply them by?
Sine over cosine.
No, what is it I want to get rid of? My denominator.
Cosine over sine.
Yeah, I'm gonna know just cosine and then cosine. Because that's like multiplying by 1. In the numerator, yeah, no, I distribute. What am I left with?
One plus sine.
Yep, 1 plus sine of theta. In the denominator, what am I left with?
One minus sine.
Ooh, I'm starting to get bouncy legs because yeah, see, I'm peaking at, you know, I need to get up to there, but I'm peaking it here and I'm going, ooh, what, yeah, help me. What should I do now?
Multiply by the reciprocal.
No, I can't do that. I can only
is-
multiply by something over something.
1
Yes.
minus sine of beta.
Okay, so if I did one, look at this. And then look at this. You were really, really close. I
Is
don't want,
1 plus sine of.
yeah, I'm gonna multiply by 1 plus sine of theta. Anything times itself becomes 1 plus sine of theta squared. Yay. Over. This is the product of a sum and a difference again. So I know that outer and inner is going to cancel. This is going to give me 1
Minus sine of beta.
1 minus sine squared of theta. And I know what 1 minus sine squared of theta is. What's that become?
Cosine squared theta.
Yeah, so now I have the quantity 1 plus sine theta squared over the cosine squared of theta. And I'm going, oh yeah, if I just multiply this by itself, I get 1 plus 2 sine theta plus sine squared of theta over the cosine squared of theta. And you can't see it so well. And I'm going, yes, that's what I wanted. My big help was I got so far and I couldn't get to here, but I was able to get to there. So when I peeked over, you know, I got to here and I peeked over, so, oh, I know what I need to make the numerator. So I multiplied top and bottom by 1.
So the result is a result of factorization, and I got the 1 plus 2 sine theta plus sine.
Sine squared of theta, that's correct. And I apologize for the sloppy handwriting. I get excited. I'm so excited. I just can't hide. I'm about to lose control and I think I like it. So let's